Hi, I'm following along with Paul McWhorter's Raspberry Pi Pico W lessons. We're on number 7. And today he mainly went over the homework he gave us last week where we were controlling 3 LEDs in sequence based on a potentiometer reading. Basically, we were doing it so we could use our slope math to find our numbers to when to turn a LED on and everything. So it was a good reference. He didn't really leave us any homework except he said there's something wrong with this code that he's got here, and he wanted to know what was wrong with it. And um, just as a quick thing, so you're walking through here with a my val, and you got if it's less than 80, you're going to do this. So let's say if our my val was 98 at this point. So if it's less than 80 and my val is less than 80, that's going to be false. So it's not going to do this section. But then you go down to this one and it says if my val is greater than or equal to 80, which it is, then that equates to true. So it's actually going to turn flip these values here and have the yellow come on. But it's only going to stay on for a fraction of a second because when you come down here, this is really where you want it. And that's when, if it's 98, then it's greater than or equal to 98, then that's where you're going to turn your red on and turn the yellow back off. So the yellow is going to be on for just a fraction of a second. And Paul will get into this, but an and statement in this if will help us with that. So he'll talk about that next time. Anyhow, when I was watching it and he didn't have any homework for it, I said, well, we got the potentiometer hooked up and we're having fun with the slope equation and everything. What else can we control with it? So a couple days ago, I did a video revisiting a project, Arduino project I did back in 2016 with my teen club that I was leading back then. And it had servos controlling a walking robot. And I thought, oh, well, let's try a servo. I know this is not beginner stuff, and Paul will probably get to that in 20 lessons or so, but didn't have nothing better to do, so I figured I'd go ahead and show how I did that. So let's bring up Thorny. And so this is the equation that I got, and we're importing our libraries or our modules. They're called modules in Python. So I know, hard to get out of the idea of calling them libraries. But we got our ADC pin down here, but we also, for our servo, we're not using a module or anything to control the servo. There are modules out there like the Pico Zero that'll do it, but to show the math, I wanted to do it this way. So we're just setting the frequency to 50. We're picking a pin to put our PWM on. And when we go to control it, what we're controlling is the duty cycle on the square wave, the 50 hertz square wave, how long it's on for compared to how long it's off for. And from our I brought these numbers over or close to it from when we were doing it on the Raspberry Pi. So Paul had showed us on the regular Raspberry Pi how to do this. So this is a review for me. I went back and looked at that one. Made real easy to figure out what we're doing here. So we're doing, like I said, our potentiometer range is from 240 to 65, 535. But our range that we're going to need for our duty cycle is from 1600 to 8200. So we're putting that into our slope equation here and getting the result, returning the results. So we're doing that, and like I said, we're returning integers. I don't don't want any fractions. I think this duty cycle has to be in whole numbers anyhow, so that's why we're returning integers. But in our while true, what we're doing is we're reading our potentiometer just like we did before, and then we're changing that reading, the pot read reading, into using the math up here and getting the scaled value that equates to the this scale here, 1600, 8200, and then all we're doing, we're calling it, giving it the variable position, and then we're just setting the duty cycle to that position. I'm printing it out here, and then just 5/100ths of a second sleep, and we're go back and do the while true again. And so I got it set up, and I actually have it set up on, let's see if it shows up. I've got too many things on the screen here. So let's slide this over. So you can see the Picos there, but we're just worried about the servo and the thing. So let's go ahead and run this code. All right, so our servo went to whatever the position of the potentiometer is now. We're only getting 14, 13 frames a second, so it's a lot smoother than what it looks like on the screen. It's really not that good. So you can see as I'm spinning the screwdriver, the pot moves. If I go all the way around, so it's about straight up and down on the video, and then so now we'll go back the other way. It's a little more than 180 degrees because it was kind of straight up and down. So we're going over 180 degrees, but you get the idea. So on the Arduino examples, they call this the servo knob example. And on the Arduino, you can do it in about half the code that they're doing here, but you're not having to do all the equations. You got a servo library behind the scenes, and you just give it a reading between 0 and 180, and it'll adjust it for you. So let's see, get rid of all that stuff. So I'm not going to use that camera there anymore. Let's get this back out where we can see it. So anyhow, so I got that done, and that was pretty good. And I was thinking to myself, when I was talking about that robot project, that we found a servo library that you could slow down with this, even the Pico Zero servo library. You set a thing, and it's going to go as quick as it can, as fast as it can spin to that position. So you would either have to do a lot of calculations in between or whatever to do that, or you could, do whatever you wanted. But if you wanted to have more than one servo, then that would be a problem, because if you're delaying or sleeping in between them, then you're not doing all that. So I looked around. There's not really a servo library that works with the Pico out there that you could set to have a slow move on it. There was one for the ESP ones. They have hardware interrupts on them, so it was a little bit easier to do that, I guess, or just nobody's taking the time. The Pico hasn't been around long enough that haven't taken the time to do a slow move library with it. So I decided I was going to go ahead and make a slow move library for the doing this. So a lot of times when you're doing a robot project, you want to move multiple servos to a new position, but you want to do it in about the same amount of time, maybe a 3/4 of a second, or whatever you decide you want to move it. But if you just tell it to move to those positions, it's going to go as fast as it can to it, and you can only do one at a time. So my criteria for this library was to have it so that you can have multiple servos, and that you could specify how long you wanted it to take to go the distance between where it's sitting now to where it is the next time, or what your destination is. So that was important to me, and like I say, I'm always looking at documentation and learning more about the Pico as I go. So there's a lot of stuff in here that probably Paul will never touch on in everything, but some of it he might. And so Paul actually showed us how to do classes in regular Python. I think it was VPython we did classes in, and so I learned that part of it from him and everything. But some of this other stuff, the timers and stuff, that probably won't get to on this. So again, we're just importing what we need. We don't really need sleep for our class, but when you have to manage time when you're setting your servos down here, so you actually have to sleep while they're working. You can tell it to work, but you can't go and just do it, so you got to sleep in between them. So that's a good thing. So I don't know how much of this I want to go into, but one cool thing is that we're using this timer down here. And where's that at? Oh, here it is. Okay. So we have this timer thing where you can set up it's not a hardware interrupt timer, but they use something, I was reading a little bit about it, something like called a scheduler in the background on MicroPython. And you can have these timers in there, and they'll set a flag every time that you do this, and the code will actually go off like a interrupt and go off, stop what it's doing, and go off and find do whatever you're telling it to do here. So we're doing like this is in milliseconds, 10 milliseconds, and it's periodic, so it's going to keep doing it over and over again until the program stops. And what it does is when this timer fires off, it uses this callback reference here and goes to that function. So this function is actually outside of the class. Just the way I decided to do it, it might work inside the class, but I just wanted it outside the class. But what it's doing is that you can actually, because down here, when we initialize each one of our servos, we give it a name, and we can actually save each one of those names into a list. So as we do this, we're saving our names into this instance list. So if we got one servo in there, or we got 10 servos in there, there's going to be a list of them. So, and we can access this list from outside of it by calling slowmove.instance list, which we do up here, slowmove.instance list. So we're saying we're working through the whole list. And what we're doing is, like I said, if I call it Servo 1, it's going to, that'd be the first thing. And it's going to say Servo 1.move. So it's going to actually go down here and do this move function that I got. So I put a single, I don't know whether this is proper or not, but I put a single underline in front of this to show that this shouldn't be called from outside the function. You could call it, but this is just reminding me that this isn't one that we call from outside the function. We or outside from our normal program, that it's only used for this updating things. So like I said, so it's going to go down and it's going to do the first servo, and then it's going to go back up and do the second servo, third servo, how many ever you got. And this is moving it. And we are actually keeping track of a couple different things here. We got our pulse width in here, max and min. And I start out in the middle somewhere. 4,900 is about in the middle. So we got that, and we save them as selfs down here. We also set our frequency, do our normal things we have to do with that, and our pin. We're bringing in our pin. But we're also doing, keeping track of our current value, duty cycle, but I call it pulse width here. It's our duty cycle is what we're actually keeping track of. So I could have called it DC, but I figured pulse width, that's what came to mind. So that's what I did. And then we are able to, I also have a variable called our destination, so that we can keep track of where we want to go to. So we know where we are and we know where we want to go to. And so let's go down here, and I know that this is over top of people's heads, so it's over. It was about the limit of what I could do on this. I'm pretty good at doing classes in Arduino, but Python's a little different. So, but it's similar. So first thing you do, like I say, you initialize a servo, but then when you want to move it, or we don't call that. When you want to set the angle, you give it an angle, and then you also give it a second, you can give it a second argument that's optional, that how long you want it to take to get there. So if you don't add a second argument, this is how you tell it. A lot of our methods, you can put 1, 2, or 3, whatever you need as far as arguments when you call it. But if you don't give it certain ones, then and you have give a value for it in your call here, you don't necessarily need it. So you'll see that that if you don't do it, then it'll just automatically down here it's going to, and this is keeping our angle in bounds. So in other words, if we're going from 0 to 180, so if you said I want a 360-degree angle, this is going to limit it. It's going to bounce it back to 180. This equation here, using the Python max and min values, lets you make sure that you keep it in bounds. So that's all that's doing. It's taking the angle and making sure it's in bounds. So if it's out of bounds, if this was a negative number or whatever, then it would be, bring it back to 0. Or if it was 300, it would bring it back to 180. So, and this is where we're doing our math. I took all that math, the slope math that Paul was doing, because we're going from the min and max, which is what 1600 and 8200. These are also optional things. You can add them in your when you initialize a pin. I mean a servo, or you can just let the um, uh, defaults be in there. So, but you gotta. This is where you're going between 1600 and 8200, and the output range is 0 to 180. So this math is doing uh, all in one line what Paul's math does. So we got that going on. And that is what we're doing. And that actually calculates, actually, we're going from 180 to those numbers. That rate, we're going, I said it backwards. We're going from 0 to 180 to those numbers. And that's what we're calling our pulse width destination, or des. And that's where we're getting that. And then so we're checking here. This is making sure it's not a negative number for the milliseconds that if you put in your milliseconds, it didn't put in a negative number. And then if you didn't put a negative number and it's 0, then we have these things called ticks to go. So what I decided to do was to take your move is going to be in milliseconds that we're going to bring in. So if you want 1 second to get from start to finish, we're going to divide that by 10. Divide that by 10 to get how many ticks it's going to be. So if we had 1,000 milliseconds divided by 10, there would be 100 ticks. So you would actually move that 100 times to get it between wherever to start and wherever to finish is. Now, if you're going from 0 to 180 on that, your ticks or your move amount, each tick is going to be more. But if you're only going 10 degrees, your tick amount, it might only be, it might skip several because it's doing integer math. So it's only going to do only when the integer changes is when it's going to actually call it to move. So we're doing it that way. And all we're doing, because these are self dot tick, these are class variables, and class variables are the same as global variables. So, and like I said, the self is like servo.1 ticks to go, or is a different value than if you had a servo2 dot ticks to go. So it's going to keep track of those as separate variables for each servo you bring in. So that, they're global, so you can use them whenever you're switching between whichever servo you want to do. So, and then the move part of it, like I said, this is where it does the math. It divides. You take the difference. So we got destination minus current. So you're finding out the difference in between the two for this tick. And we are taking the difference divided by how many ticks to go. So if we had 100 and we're down to 50 ticks, then it's going to take this difference and divide it by 50 because we want that slice of the pie. And then we're going to add that to whatever the current is. So if this ends up being, now like I said, this is also in pulse width, so it probably going to be, maybe it's 25 or something in the pulse width thing, and you end up with, so it's going to add 25 to the current. Now this also works different. So if you had a pulse width, if you wanted to go in the other direction, if this was if your destination was 20 degrees or 20, whatever the pulse width is for 20 degrees, and you were already at 50 degrees, this would end up being a negative number, and that works out fine. So your difference is going to be negative. So you're going to end up with a negative that you're going to add to this. So it's actually going to subtract from your pulse width current. And then we subtract one of the ticks from it. And as long as our ticks are above 0, then we keep doing that. And we set our pulse width every time through there. And like I said, this is actually called from our timer up here outside here. And this happens every 10 milliseconds that it's going to do that. So how it works in reality is you have to initialize a servo. So you give it a name and you say, and the class is slow servo, and then you put the pin number. Now, like I said, we could have put in our own PW max and PW mins and PW current as well in here, but we don't really need to put those unless there's a reason to. You might want to put your current if you wanted your servo to start at a certain spot. You'll see when this program starts that the servo, very first time the servo might spin around halfway, and it's going to go all the way around, you know, it's just going to go normal. It's not going to go slow. But I have 2 servos set up here. So we're having servo 1, servo 2. And then the way we do it is we set the angle. And like I said, we're going to set servo 1 to 170 and servo 2 to 20. But they're both going to take 2,000 milliseconds or 2 seconds to get there. And then, like I said before, you have to keep track of your sleep because you really can't do anything when you're, if you want these to make their full range. You can go ahead and change them if before they're timed out, and it won't crash the program. It'll just start going to your new destination. So if you call another set angle before they finish, then it's going to change that, and it's going to go to the start looking for the new angle, and it's going to go over that same whatever time period you got that many of ticks to go you're going to have. So anyhow, that's what we're doing. I found out that your easiest way that I was able to get your servos to release at the end of the program was to use this machine.reset. Because you know, like I said, you don't, because these are in a class up here, you really don't know which ones you got. You could possibly call all your, you know, your deinitialize all your servos up here if you wanted to, all your pulse width if you wanted to, but machine.reset seems to work. It gives weird things down the bottom here, but that's okay. So anyhow, that's the program. I guess the best thing to do is to show it. With the Raspberry Pi camera being so few frames per second, I'm actually going to bring this up a little bit bigger, just show them on the screen. I'll hold them in my hand if I can get a hold of them without unplugging them. So let me try to do this. So like I said, they're going to go from server 1's going to go from 170 to 1. Server 2 is going to go just between 20 and 50. So we'll get them going and we'll show it maybe if I can. So let's run it. All right. So see how they're both finishing at the same time? Now, if you had a robot like BBF has or something like that, and you wanted to move your leg and your hip or whatever, your hip probably is not going to move very much. So that might be closer to what this servo is doing, just moving a little bit, but you don't want it to move so quick. So, but then like maybe your thigh bone or whatever, or your knee is going to need a lot of movement, but you want it to happen over the same amount of time. So, that's what the library can do. So it's going to let you set up. I haven't tried, see how many servos you can set up before you run out of time to control them, but probably quite a few, I would hope. And said, be nice. Like say, I know that some of the modules in here go back to the C language to get the efficiency of the C language, of the compiled language out of that. And that's way beyond me. So, but anyhow, we got a hip joint moving a little bit and the leg joint moving a little bit if you were on a robot. And, I think BBF's on his page says there's 17 degrees of freedom. So I don't know whether it would take 17 servos, but it probably might. But anyhow, that's how you would do robot control, servo robot control in Python. This video has gone quite long enough, but thought it was interesting that I was able to get this worked out. It only took about 50 lines of code or whatever. Anyhow, thanks for watching. Have a good night.